Welcome to Unit 2. This is Lesson 1, Average Rate of Change. To understand average rate of change, we have to first review the idea of slope. What is slope? Well, slope is the rate of change. So it's how quickly y is changing, which is also called the rise, change in y, divided by how fast x is changing, which is also called the run. Let's look at some examples. Example 1. What is the slope of y equals 3x plus 1? Let's look at the graph. So y equals 3x plus 1. Here's our line. Let's pick 2 points. Here's a point. 0, 1 is a point on the graph. Let's call this A. Point A. 1, 4 is also a point on the graph. Let's call this point B. Well, between point A and point B, we know that the line has gone to the right 1, and it has gone up 1, 2, 3. So that's why the slope, we're going to use m for slope, is the change in y, or the rise, which is 3, over the change in x, which is the run, which is 1. 3 divided by 1 is 3. So that's why the slope of this line, y equals 3x plus 1, is 3. So the slope is 3. Let's answer the question. The slope is 3 because when x increases by 1, y increases by 3. It's telling us how fast y is changing compared to x. Notice that it doesn't matter what points we choose. For example, we can choose 2 different points. This time, let's try the point -1, -2, which is also on the line. I'm going to call this point C. And let's try the point 2, 7, which is D. This time we're going from C to D instead of from A to B. Okay, so this time we're going to go from C to D. Some students might say, well, okay, let's see how much we go to the right. 1, 2, 3. We go to the right 3. How much we go up the rise? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the slope is rise over run. It went up 9, went across 3. 9 divided by 3 is also 3. Of course, we get the same answer because it doesn't matter where we look. It is a straight line. The rate of change is constant. Constant means it stays the same. So we know for this one, a straight line, we know that the rate of change is constant, stays the same, and it is 3. That's why we can say that the slope of the line is 3. So that's just a review. Let's look at one more example. Example 2. The slope of y equals 2/3 x plus 4. Let's type that in. Y equals 2/3 x plus 4. All right. Again, we pick 2 points. 0, 4 is an easy point to pick, the y-intercept. You don't have to pick 0.4 as you saw earlier, but let's use an easy point. We said that the line goes up here. Oh, there's another easy point. 3, 6. Let's call that B. All right. How much are we going to the right? 1, 2, 3. How much are we going up? 1, 2. Remember, slope is rise, change in y, over 1, change in x. So it's 2 over 3. That's the slope. In other words, the slope of y equals 2/3 x plus 4 is 2 over 3 because when x increases by 2, y increases by 3. So why is this a fraction? Well, this is just to say that when x increases by 2, y increases by 3. We can also say equivalently, when x increases by 1, y increases by 2/3. So that's why the slope is 2/3. We can see that when we go back to the graph. When x increases by 1, let's erase this. When x increases by 1, y increases by about 2/3. In fact, it's exactly 2/3. Yeah, and we can see that's right. So that's slope. Next, we are going to extend our learning from algebra. This is just algebra. Now we're going to move on to the calculus part. In calculus, actually, sorry about that. Let's look at slope in context first. Let's look at speed. Let's say that the distance traveled by a car is d, and the time that we have passed, the time elapsed, is t. The distance traveled is in meters. The time elapsed is in seconds. We know that distance for a car traveling at constant speed is d equals st. Notice that this is very similar. This is equivalent to, this is really the same as y equals mx. We see that y is like the distance, x is like the time, and so the slope is our speed. Because speed is rate of change of distance compared to time. So if d equals 4t, what is the speed? Well, this one, that's the slope. So the speed is 4. If you think about units, well, speed is a slope, is a rate of change. For slope, we have delta. We have change in y over change in x. Here we have change in distance over change in time. The change in distance, so every 4 meters, the car moves in 1 second. So that's why the speed has to be meters per second. Okay. All right. All right, now let's go from algebra to calculus. This time, we're not just going to look at a straight line, we'll look at a curve. In particular, we're going to look at a quadratic equation, y equals x squared. Let's graph it and see what it looks like. Remember that this is, you might remember this is called a parabola. It's a curve. Well, question, what is the slope of y equals x squared? Well, it's hard to tell. Remember, if we go back to straight lines, y equals 3x has a larger slope than y equals 2x because it's more steep. Y equals 1x, and if it's negative, it goes the other way, and so forth, right? So slope tells us, the direction the line is going. The problem is for y equals x squared, the direction the line is going changes. At the beginning, it's coming down really quickly, and then it slows down, and then it goes up, and it goes up faster and faster and faster. For example, if we're going to look at our line, say here, y equals x squared around, say, x equals 3. Here, our line is going up pretty quickly. But if we look at our line at x equals 0.5, it's going more slowly. So there's no single slope. And in fact, if we're looking at x equals, say, negative 2, the slope should be negative. It's coming down. What does that mean? That means that the slope changes. There is no single answer. So this is kind of a trick question. What is the slope? Well, of y equals x squared, there's no single slope. Yeah, there is no single slope to this. Alright, well, if there's no single slope, what can we do? Actually, it's still okay, even if there's no single slope. Instead, we can think about how quickly our graph is changing in certain regions. we can approximate. We can say that, our slope in this area is about this. The slope in this area is about this. The slope in this area of the graph is about this. And this concept is the main lesson. This is called the average rate of change. So again, the rate of change, the slope, is how fast y is changing compared to x. Lines that are not straight do not have a single slope. Instead, we can find the average rate of change for a given interval. For example, let's go to our graph. Let's take an interval. Interval is just any area. For this one, let's think about the area, the interval x equals 1 to x equals 3. So here's x equals 1. Is at 1, 1. When x equals 3, 3 squared is 9. So let's call x2 3. Then f of x2 will be 9. Okay. We don't have a single slope because it's not a straight line, but we can estimate by drawing a straight line in between two points. Here's our straight line from 1, 1 to 3, 9. That's a straight line. There is a single slope for the straight line. What is the slope of this line? Well, that's what we reviewed earlier. We go up by 2. We go across. We go to the right by 2. That's the run. We go up by 1, 2, 3, 4, 5, 6, 7, 8. So the slope of this line is 8 over 2, which is 4. What we can say then is that the average rate of change of our graph y equals x squared from x equals 1 to x equals 3, the average rate of change is just 4. Okay. To summarize the general idea, for any function f of x, the average rate of change from x1 to x2, in our example earlier, x1 was 1, x2 is 3, is just f of x2 minus f of x1. That's equivalent to the y2 minus y1 of the slope formula. That's the rise over x2 minus x1. That's the run. Okay. Let's look at a couple of examples. Example problem: f of x equals x squared plus 3x. We want to find the average rate of change of f of x from x equals 0 to x equals 2. Well, that's part A anyway. Alright, let's recall our definition of average rate of change. F of x2 minus f of x1 divided by x2 minus x1. Alright. Okay, so let's apply our definition. So we know that x2 is 0. X2 is 2, and let's be more careful. X1 is 0, x2 is 2, because we're going from 0 to 2. So x1 is 0, x2 is 2. When x equals 0, our function is f of x equals x squared plus 3x. While when x is 0, f of 0 is just 0 squared plus 3 times 0, which is 0. So f of 0 is 0. But what we really did was f of 2 minus f of 0 over 2 minus 0. That's the average rate of change. And we know that f of 0 is 0. F of 2 is 2 squared. F of 2 is 2 squared plus 3 times 2. That's 4 plus 6, which is 10. So f of 2 is 10. So the average rate of change, well, we go up from 0 to 10. We go across from 0 to 2. 10 over 2 is 5. So the average rate of change of our function from 0 to 2 is 5. This should make sense. Let's go to our graph. Let's actually bring down the calculations. Our new equation is x squared plus 3x. So we have a new equation now. And we're going from 0 to 2. X equals 0 to x equals 2. When x equals 0, f of x also equals 0. When x equals 2, f of x is equal to 10. So we're looking at these 2 points, really. 0, 0, and 2, 10. We go up 10, we go across 2. That's why the average rate of change is 5. Okay. All right, so that's part A. Part B. I'm going to change the color. Okay. Now we want to find the average rate of change from x equals 5 to x equals 7. Well, that's just f of 7 minus f of 5 over 7 minus 5. Okay. F of 7 is 7 squared plus 3 times 7. That's 49 plus 21. That's 70. F of 5 is 5 squared, 25, plus 3 times 5, 15. 25 plus 15 is 40. So 70 minus 40, which is 30, over 7 minus 5, which is 2. 30 divided by 2 is 15. So the average rate of change of f of x from x equals 5 to x equals 7 is 15. Are the answers to A and B equal? Well, the average rate of change from 0 to 2 is 5. From 5 to 7 is 15. They are, of course, not equal. The average rate of change is greater from x equals 5 to x equals 7. So when x is greater, the average rate of change is also greater. It's going up faster. Let's look at our graph to see what that looks like. X squared plus 3x. Let's zoom out on our graph. And we said, yeah, from 0 to 2, that's this region, it's going up, I wouldn't say slowly, but certainly from 3 to 5, it's going up faster. From 3 to 5, it's going up faster. No. So that's why the average rate of change depends on our interval. From x equals what to x equals what. That's our interval. Okay. Finally, let's go back to our context slope. The distance traveled, example problem 2. The distance traveled by a car is described by the function d equals t squared plus 2t plus 3, where d is distance traveled in meters and t is time elapsed in seconds. We want to know, like, how fast is the car going, average speed of the car, between t equals 3 seconds and t equals 6 seconds. That's really just the average rate of change. But it's a weird problem that we're in context. So same formula. In other words, it's going to be instead of f of x, we have d of t. So we have d of 6 minus d of 3 over 6 minus 3. That's going to be our answer. Well, let's evaluate d of 6 and d of 3. d6 is 6 squared plus 2 times 6 plus 3. That's 18. Sorry, nope, not 18. That's 36 plus 12 plus 3. That's 51. D of 3 I'm not going to write out details, but it's 3 squared, which is 9, plus 2 times 3, which is 6, which is 15, plus 3, which is 18. So d of 3 is 18. So the average rate of change is d6, 51, minus d3, which is 18, over 6 minus 3. So it's 33 over 3, so it's 11. Remember our units? Well, it's change in d over change in t, so it's meters over seconds. In other words, during that time, on average, we know the car is speeding up, but on average, every second the car goes 11 meters. And that is the average rate of change.